So in the yesterday's class, we came to know that what would be how much number of the atoms are present in a primitive unit cell, in a body-centered unit cell, and in a face-centered unit cell. So in the today's lecture, we are going to see that how these atoms are arranged in a 3 dimensions. So instead of going at a time to the 3 dimensions, now first and the foremost thing, let us deal by dimension-wise dimension. That is, first we will be seeing in 1 dimension how the molecules are arranged, then in 2 dimensions, and at last to have a clear picture by taking the latest examples, we will be seeing that how in 3 dimensions the particles will be arranged. So now let us first see under the topic called as that of your close packing in 1 dimension. Close packing in 1 dimension. Okay. You have to just assume, as I have mentioned over here we are considering the particles as that of your hard spheres. Hard spheres, remember. So 1 dimension means what? Of course 3 dimensions mean it will be your x-axis, y-axis and z-axis. So in 1 dimension means I am taking any one of these axes. For my general case, I am taking 1 dimension as method of your x-axis. So how we will be arranging the atoms in one axis? Just we are having only one step. That is, you are just arranging in a single row. This is your one atom. This is your another atom. This is your another atom. So this will be the way how we can arrange our atoms. So here, even though we are considering this one as hard spheres, but you have to remember that they may be your constituent particles, either atoms or molecules or ions. Just we are seeing that how they are packed. Close packing means how much closely they are packed in 1 dimension. So there is only one possibility, and that possibility is you can just arrange in a single row. Single row. So if I ask you what is its coordination number? So coordination number means nothing. If I consider this particle, okay, to how much nearest neighbors it has been directly attached to. So that represents your coordination number. That is, this atom or the particle or the sphere has been attached to the one more sphere and also one more sphere directly. So the coordination number in a close packing 1 dimension is, if I write as a coordination number is equals to 2. So how will you define the coordination number? The number of the nearest neighbors of a particle. What this is, the number of the nearest neighbors of a particle is called as that of your coordination number. So close packing in 1 dimension, only one possibility is there, that is you are arranging the spheres in just a single row. Remember, just a single row. Here we are getting the coordination number is equals to 2. Coming to the next close packing, that is close packing in 2 dimension. In 2 dimension, that is, of course, now I have to take up with respect to 2 axes, x-axis as well as my y-axis. So there are 2 possibilities. So first possibility, let me just draw it. How we are going to draw it? For example, if I consider this is my first row along x-axis, like this. So there is a possibility that if I am placing another row on top of it in such a way that the another row just lies above the first row. That is, on this sphere itself, you may get one more sphere like this, like this, like this, like this. Able to see? Similarly, there's no space at the top, so I'm just writing at the bottom. Just to the first layer itself, I'm drawing a one more layer. From the first row, the second row I have written. So what I have done, this is your x-axis, this is your y-axis. That's it. So if I am taking, for example, this, I want to measure the coordination number. So if you just see, this is in contact with the sphere, this is in contact with the sphere, okay, this is in contact with the sphere, this is in contact with this sphere. So if I am going to join their centers, okay, if I am going to join their centers, what you are getting? A square you are getting. Alva? a square you're getting. So this close packing in a 2-dimension is called as that of your square close packing. Square close packing. So what we have done, close packing in a 2-dimension, we took first a row, and on that row itself I have placed another row. For example, if I consider this arrangement as A arrangement, okay, the above will be also an A arrangement, above will also be an A arrangement. So this type of an arrangement is of the type of how AA type arrangement. So in an AA type arrangement with respect to close packing in a 2-dimension, we are getting the coordination number. What will be the coordination number over here? Very good. That is equals to 4. Because we had to calculate the number of the neighboring particles which is in contact with our main particle. So this is if I consider it's a main particle. What are the numbers? 1, 2, 3, 4. So the coordination number is 4. In which type of a close packing? Square close packing. Why does it has got the term as a square? Because when you are joining its neighboring particles through their centers, we are getting a square part. So this is first in a 2-dimension first type. When you are doing with respect to that of your second type, how you can do with it? So I am going, if I am just taking in this way as my spheres, the first row spheres as usual, I have chosen earlier. Okay. So now what I am going to do is the second layer is being placed with respect to the depressions of the first layer. Has been placed with respect to the depressions of the first layer. Let me go on with it. So if I choose in this way, it has been fit in the depressions. Can you see here what we did? The second layer was placed just above the first layer. But in the second case, what I am doing, I am just placing my spheres in the depression. So this is what this 2 spheres depression is, this one. This 2 spheres depression is this one. So how are you going to write it? In this way you are going to write. Like this, like this, like this, and like this. Able to see? So the second layer has been, or the second row we can say, the second row has been placed. I'm not saying as a layer, sorry. It's a second row. Second row has been placed in the depression of the first row. The same way when you're going on the top of it, how will you write it? In this way I can write it. Yeah. Like this, like this. It is just similar to how your fruits have been arranged in the fruit stalls, if you have observed it. Yeah. So if I am just taking into contact of these spheres like this sphere. Yeah. So what are those contacts? You can just see. So this is the contact. This is in contact. Alva. Even this is in contact. This is in contact. And to that of your, this is in contact, this is in contact. So if I am just drawing a line from their centers, what you are going to get? A hexagon, like that of your hexane ring is obtained. Can you see? Since then hexane ring is obtained, it is called as hexagonal close packing. Hexagonal close packing. You can only see what will be its coordination number then. 1, 2, 3, 4, 5, 6. The nearest neighbor particles which is in contact with the main particle. Okay. So here the coordination number is 6. So what we have observed in close packing in 1 dimension, there is only one possibility. You have to place just a row, a single row where the coordination number is 2. Close packing in 2 dimension, we have seen that we are having 2 possibilities. The first possibility that you are placing the second row on that of your first row, similar first row. If the first row arrangement, if I am taking it as A type, the second row will be also of A type. So if I am measuring, if I am joining the lines of the nearest neighboring particles, I am getting a square. So this type of arrangement of a close packing is called as square close packing with a coordination number of 4. In the second case, what I have done, I have just arranged my second row to that of your depressions of the first row. just similar to that of your how you're seeing in your fruit stalls, how the fruits are arranged. If you're taking your santras or musumbis, how they will be arranged, same way I have arranged in the depression. Then first row depression, the second row has been arranged. So if I'm just taking their nearest neighbor particles and joining the lines to their centers, I am getting an hexagon. A hexagon is obtained, so it's called as an hexagonal close packing with a coordination number of 6. What type of an arrangement it would be? If I consider this one as of my A type, of course this is not same, so I will be taking it as my B type. Alva. So the arrangement is like AB type structure. AB arrangement. So this type of an arrangement is observed in that of your hexagonal close packing. So which is your close packing in that of your 2 dimension. So in my next video, we'll be going the detailed part, okay, with respect to the close packing in 3 dimensions with some demonstrations.